Hello, everybody. Welcome to Calculus 2.5, the power rule of AB and BC AP. All right, let's get started. So, as you learned in the lesson, when you have x to the n to get the derivative, you move the n to the front and then minus 1. So, uh, your derivative will look like this: n times x to the n minus 1. And so we're going to be exploring different forms of this throughout the entire practice. All right. Whoops. Okay. Number 1, we have y equals x to the 7th power. So we move our 7 to the front. And then what's 7 minus 1? Well, that's simply 6. I'm not going to write the dy dx because it's going to look sloppy. And you guys know that the answer I put here is going to be a derivative. But you should put dy dx or else it will be wrong. Okay. Y equals x. So x is x to the 1. So we have 1x to the 1 minus 1 is 0. What's anything to the 0? That's 1. And so your final answer is 1. Okay. Y equals x to the pi. So we move the pi to the front and then keep the x. Pi minus 1. Well, we can't do anything with that, so we're going to leave it as pi minus 1. All right, so this next one is where uh, things can get a little tricky, but if you know your exponent rules, it should be pretty straightforward. All right, so we have x 1 over x to the 5th, but we can't really use the power rule yet because our power is the denominator. So we have to move it to the top. So we can rewrite this, remember, to if you move an exponent to the top or bottom, depending on where it is, it becomes negative. And so this becomes x to the negative 5. And now we can use our power rule because our function is in x to the n, right? Okay. So move the 5 to the front. Negative 5 minus 1, that is negative 6. And then our final answer, and now we want to have the x as positive. So we're going to move it back to the denominator. So our exponent will become positive. Pretty straightforward. Let's do another one. 5. Y equals 1 over x to the fourth root of x. So we're going to rewrite this so that we have exponents instead of a root. So 1 over x to the fourth root of x is equal to, and the pen's not working. Okay. Is equal to 1 over x to the 1/4. Then if you remember last problem, we made that 1/4 negative so that we can now have our function as x to the n form. And now simply move the negative 1/4 to the front. X negative 1/4 minus 1. Well, negative 1/4 minus 1 is the same as negative 1/4 minus 4 over 4, which is negative 5 over 4. So our final answer is negative 1 over 4 times x to the 5 over 4. You could also put that in root form, but I'm not going to do that because I don't have space. Let me erase this. Okay. Next problem. We have y equals ninth root of x to the 4th. So remember how to convert radical a root into exponent. This this interior, that's gonna be your numerator, and this is gonna be your denominator. So x to the 4 over 9, right? Our 4 is inside, so it's gonna be in the numerator. Our 9 is on the outside, so it's gonna be a denominator. Now we can use a power rule. So 4 over 9 goes to the front. X 4 over 9 minus 1, it's going to give us negative 5 over 9. And then final answer, 4 over 9 x to the 5 over 9. All right. Again, we're going to do the same thing as we did last problem. So this is just x cube root of x, right? But let's say you forget how to convert that. So that x has a 1 as its power. And so since 1 is in the inside, 1 is going to be our numerator. And 3 on the outside, our denominator. Now that it's in exponential form, we can do no, not product rule, that's later. Power rule. Let's move the 1/3 to the front, x, and then 1/3 minus 1, negative 2 over 3. And then final answer is going to be 1 over 3x to the 2 over 3. All right, perfect. A little bit sloppy, but you get the idea. Okay, next problem. It's already in x to the n, and so all we have to do is bring the e down, right? That's our power. So bring it down. X stays the same, and then e minus 1. All right, two more of these. This one's a little bit tricky, but again, if you know your power rule, if you know your exponent rules, you're going to be able to solve this with ease. So we have y equals x over cube root of x. Uh, Again, you want to try to get your functions into exponentials. You want to get it into the form x to the n. So how do we do that? Well, remember, x over n divided by x minus m equals x to the n minus m. Okay? Now, that being said, we're going to use the same idea here. So, x to the 1, and then we know that cube root of x is x to the 1/3, and so we just subtract the powers, right? 1 minus 1/3 is 2/3. Now it's in x to the n, so we can move the 2/3 down there. 2/3 minus 1, negative 1/3. We write this as 2 over 3 times cube root of x. All right, last one. Instead of dividing, we have multiplication. And so remember that x to the n times x to the m equals x to the n plus m. Okay? That is our multiplication exponent rule. And so when you have two exponents being multiplied, you are going to add the exponent. Okay. So x squared, and then we want to rewrite that radical into an exponent. So remember, 5 is on the inside, so that is going to be our numerator. 6 on the outside, it's our denominator. 2 plus 5 over 6, we can make 2 12 over 6. 12 plus 5 over 6 is going to be 17 over 6. All right, I probably should have written an x there. But yeah, x is a 17 over 6. Now we can use our power rule, bring the 17 over 6 down, and then subtract 1, which is 6 over 6, right? Because we want to subtract like this. Okay. 17 over 6 minus 6 over 6 is 11 over 6. So, like that. And then we could leave it like that, but if you want to, you can rewrite it as a radical. You would have, now remember, 11 is on the inside, 6 on the outside. So times 6 root of x to the 11. Hopefully that makes sense. I think I explained it pretty well, but I am also learning. So learning how to explain my thought process. All right. Find f prime of a for each function at the given value of a. So we have to not only find f prime of x, but we have to find it at a point. And again, we're using power rule for all of these. F of x equals x to the fourth. This is a pretty basic one. Move the 4 to the front. 4 minus 1 is 3. That is your f prime of x. And then we have to find f prime of negative 1. So we're just going to substitute in negative 1. And we get negative 4 as our final answer. Next one, f of x equals square root of x. Well, we know that a square root has a 2, right? So we're going to convert square root of x into x over 1 half. Okay, now we are going to do the power rule. So put the 1 half on the front. X stays the same. And negative 1 half. I'm going to rewrite it. 1 over 2. And then x minus 1 half, you bring it to the bottom, becomes positive. X to the 1 half. X to the 1 half is square root of x. And we're going to find it at the point 16. 1 over 2 times 16. 1 over 2 times square root of 16 is 1 over 2 times 4. 1 over 2 times 4 is 1 over 8. All right, next one. F of x equals 1 over x to the fourth. All right, so we have our exponent and denominator, and we do not have f of x in x to the n power form, and so we have to do some exponent manipulation. How do we get the x to the fourth to the numerator? We make the exponent negative. So x to the negative fourth is equal to 1 over x to the fourth. Get the derivative. Negative 4 comes to the front. X stays the same. Negative 4 minus 1 is negative 5. Can rewrite that as negative 4 over x to the fifth. Plug in 2, you get 4 over, and then 2 to the fifth is 2, 4, 8, 16, 32. Divide by 4, you get 1. Divide by 4, you get 8. So your final answer is negative 1 over 8. Okay, last one. F of x equals 1 over cube root of x. Find f prime of 27. So again, we have something in the denominator. We do not have our function in x to the n. So how do we change that? Again, we have to do exponent manipulation. And so we're going to do x cube root of x and turn that into an exponent. Cube root of x is equal to x to the 1/3. We have to know that by now. I was just explaining, how to get that, but you really should know your exponents by now and how to convert from radical to exponent. So cube root of x is x to the 1/3, and so we get 1 over x to the 1/3 Notice we still have that exponent in the denominator. We need to get into the numerator. So we make the exponent negative. Okay. Now we have it into x to the n power. So move down negative 1/3. X stays the same. Negative 1/3 minus 1 is negative 4/3. All right. So a little bit more. And then you get negative 1/3. Negative 1/3 times x to the 4/3. Okay. Now we have to find it at 27. Okay. Plug in 27 into x. You get 27 to the 4/3. If you get the cubed, if you find the cube root of 27, you get 3. 3 to the fourth power is 3, 9, 27, 81. 81 times 3 is 243. And so your answer is going to be negative 1/243. Hopefully that makes sense. What I did was I found the cube root first, and then I did to the fourth power, so that would make it a little bit easier to solve. Okay. So we are asked to find the equation of the tangent line of each function at the given value of x. So if you've noticed, the tangent line comes up pretty frequently so far in AP Calc, and it's important to remember the equation. So, but just in case you forgot, y equals y1 plus d dx or m times x minus x1. Okay. With that being said, let's start with 15. Y equals x to the third at x equals negative 2. So we have our x value. We don't have our d dx, and we don't have our y1. Okay. Let's solve for y1. Okay. Y1 is equal to negative 2 cubed equals negative 8. All right. Now we have to find our derivative. So derivative of y equals x cubed. Power rule, bring the 3 down. 3 minus 1 is 2. But we still have to find our derivative at the point. So we can't have 3x squared. 3 times negative 2 squared is going to be 12. So we have everything we need. Y1 is negative 8 plus our slope times x minus negative 2 plus 2. All right, simple as that. Next question. F of x equals x to the third over 4 at x equals 1. Let's find our function value. So y1 is equal to 4th root of 1 to the third. 1 to the third is 1. 4th root of 1 is 1. All right. D dx. So we have 4th root of x to the third. Turn that into a exponent. And now we can use the power rule. So bring the exponent to the front times x to the n minus 1. So 3 over 4 minus 1, negative 1/4, 3 over 4, and then to get it into the denominator again, we make it positive. So 3 over 4 times 4th root of 1 is going to give us our derivative, which is 3 over 4. So now we have everything. Y equals y1 plus 3 over 4 x minus x1. All right, last one is f of x equals 1 over x to the fourth at x equals 2. Let's find our function value. y1 is equal to 1 over 2 to the fourth. 2 to the fourth is 2, 4, 8, 16. So 1 over 16 is our y1. Let's find our d dx. Can be rewritten as x to the negative 4. So move the negative 4 to the front. Negative 4 minus 1 is negative 5. So rewrite this negative 4 over x to the fifth. Negative 4 over 2 to the fifth is negative 4 over 2, 4, 8, 16, 32. So that reduces to negative 1 over 8. Y equals y1 minus 1/8 x minus x1. And I did that last question pretty quick. I did skip some algebraic steps, but you should be getting quicker and recognizing things and trying to, solve things more frequently in your head. Okay, questions 18, 19. Where do the two functions listed have parallel lines, parallel tangent lines? So if you remember from algebra, parallel lines equals same slope. So if I have 3x, y equals 3x, y equals 3x plus 1, we're going to have the same slope, which means that the lines will never touch. Remember that zero solutions means that it's parallel, right? So same slope. One solution is they intersect at one point, which is different slopes, and then two solutions, that's quadratic. But anyway, I don't want to get off on a tangent here. No pun intended. Okay. So where do the two functions listed have parallel tangent lines? We're going to have parallel tangent lines when d dx for both functions are equal, right? Because if it's a parallel tangent line, we're going to have to use y equals y1 plus d dx. And so d dx has to be equal. Your slope has to be equal for both. So we're going to find the individual slopes and set them equal to each other, and then we're going to find the zeros. All right. So f prime of x equals, bring the 2 down, 2x to the 1 equals 2x. And I just wrote the 1 down so you remember you do minus 1. But once you become a pro at this, or more comfortable, I should say, obviously you're not going to have to write the 1 down. Okay, g prime of x, we have x to the fifth, x to the n form, so you just bring the 5 down. 5 minus 1 is 4, and now we set these two things equal to each other. So 2x equals 5x to the fourth. Bring them to one side. 5x to the fourth minus 2x. 0 equals x squared. 5x. Oh, not x squared. X. So that makes this 5x cubed minus 2. So x equals 0. And then our last one is going to be, well, let's just solve for it. 5x cubed equals 2. X cubed equals 2 over 5. So x equals cube root of 2 over 5. Okay, I'm going to erase this little bit right here for the next question. Okay, so we actually have to use a calculator here. So we're going to pull up our trusty Minnesota calculator. and have that thing ready. Okay, f of x equals square root of x, and g of x equals x cubed. And so we're going to actually find the derivative first and then plug those into y1, y2, find the intersection points. Bam, we have our answer. F prime of x, this is x to the 1/2. Move the 1/2 to the front. 1/2 minus 1, negative 1/2, equals 1 over 2 square root x. G prime of x, bring the 3 down. 3 minus 1 is 2. Okay, so now we're going to go into our y1. We have f prime of x is 1 over 2 square root of x. And for a y2, we have 3x squared. Okay, graph. And so you can see here we have our intersection point. We only have one. So we're going to find our intersect first curve to the right a little bit. And boom, this is our intersection point. 0.488. Sorry, not y equals, because it intersects at x, not y. Or it's asking when, not the y value. So it's 0.488, and I'm just gonna write the whole thing down. 3593. All right, beautiful. So we have a couple more questions. All right. Number 20. Limit as x approaches e of x to the third minus e to the third over x minus e. This looks very familiar to this derivative formula. The thing cooperates. Okay, so we have our f of x, and we have to find our derivative at e, right? And so f of x right here equals x cubed. So f prime of x, as we should know for power rule, is going to be 3x squared. And then it's at e, so it's going to be 3e squared. All right? I believe that makes sense. All right. So this one, it's a different definition of a derivative by limits. We've also seen it before, so shouldn't be new. F of x plus h minus f of x. Although actually this is not f of x, because I don't see an x, I just see a point 25. So I'm gonna do f of a plus h, and then we have our f of a. So our a is gonna be 5. Or not, our a is gonna be 25. Okay, over h. So this is our f of a plus h, and we can notice that that function is simply square root of x, right? If you plug in 25, you're gonna get 5, which is right here, right? This is gonna be your f of a, which is 25. Square root of 25 is 5. Okay, finding the derivative of this is, remember, x to the 1/2 is equal to square root of x. Move the square root to the front, x to the negative 1/2. 1 over 2 square root of x. We know that our f is 25. So f prime of 25 equals 1 over 2 square root of 25. Square root of 25 is 5, so 1 over 2 times 5 is 1 over 10. All right. Next question. Given f prime of x equals 1 over x and f of 2 equals 5, write an equation for the line which is tangent to the graph of f of x at one point where x equals 2. Write an equation for the line which is tangent. Okay, so this is easy. We have our x1, we have our y1, we have our f prime of x. We need to find our f prime of 2. Prime of 2, pretty straightforward, 1 over 2. And so you get y equals y1, which is 5, plus 1 half our slope times x minus x1. x1 is 2. We're going to distribute based off our answer choices. 1 half times negative 2 is negative 1. So we get 1 half x. 5 minus 1 is plus 4. That's our answer choice. Okay. 23, last one. In the figure to the right, line L is tangent to the graph of y equals x cubed at point A with coordinates a, comma a to the third. Line L crosses the x-axis at point B with coordinates b, comma 0. Find b in terms of a. So I know this question definitely seems a little daunting at first because you may be like, what do I do? Well, let's just try and see what we can do with the information that's given. So line L is tangent. Line L is tangent at y equals x to the third power. And at that point, we have coordinates a, comma a to the third. Okay, so let's try, I don't know, let's try doing a tangent line, right? I mean, we have the information to make a tangent line, and it mentions line L is tangent. So let's try a tangent line. So we have y equals, what's y1? Well, a to the third would be our y1, right? At this point, a to the third is our y1. Okay. Plus slope. What is a slope? Well, we have a curve, but we're given this function right here. And with power rule, we can find the derivative. Get 3x squared. So we're going to write 3x squared. And, well, I'll get to that in a sec. And then we have x minus our x1 is a, right? Okay. Let's try to get rid of some of these x's. Well, remember, we can't have our derivative be in the x form. We have to have our derivative at a point. And we know that at that point, right here, at this point, our x equals a. Okay? So we're going to do 3a squared. All right, we still have two unknowns, y and x. Well, now the question is asking us, find b in terms of a. So where does b come into play? Well, it says line L crosses the x-axis at point B. Crosses the x-axis, point B. B0. And so that is going to be our other pair, coordinate pair. So B is our x, 0 is our y. 0 equals a to the third plus 3a squared. B minus a. All right. So now we are going to distribute a to the third plus 3a squared b minus 3a cubed, right? All right. Notice that each term has an a in it, so we're going to factor an a out. But if we move a to the third to the left side, we can factor a 3a squared out, which gives us our b. It isolates our b, right? We have 3a squared, 3a cubed. So if we move this to the left, we can factor out on the right and then divide both sides by 3a squared to isolate our b. So let's show you how that works. So move a cubed to the left, you get negative a cubed. And then now we factor out 3a squared, gives us b minus a. So now we divide both sides by 3a squared. So b minus a equals, that 3 becomes a 1. This gets canceled out completely. So you get negative a over 3. B equals a minus a over 3. All right, I hope that makes sense. I just did some rearranging to isolate b. That's just isolating variables. It's just a skill you should have from algebra. But that's all we did, right? As far as the calculus is concerned, we found our tangent line. We were given points a comma a to the third, and then the question was asking us to find b in terms of a, and we were given coordinates with b, and so we used our tangent line to find b in terms of a. And then the next question, find the value of b when a equals 9. We're going to use this right here. B equals a equals 9. So 9 minus 9 over 3. 9 divided by 3 is 3. 9 minus 3 is 6. B equals 6. And there we go. Wow, that was a lot. But great job, guys. Made it to the end of the lesson. I hope that was helpful. Any questions, leave them down in the comments or at me in the Discord server. Thank you for watching.